This says the reduced row echelon form of a system of linear equations is given. Write the system of equations corresponding to the given matrix. Determine whether the system is consistent or inconsistent. If consistent, give the solution. So notice one thing it's saying right away is that the reduced row echelon form. So first I want to talk about that. Essentially what that means for us here is that I have 1 on the diagonals, and they call that the diagonals, and rightly so, because it's on a diagonal. And they're all 1s there. And everywhere else, there's 0s. That's called reduced row echelon form. And then if I look at the second one here, number B here, they tried to have 1 on the diagonals, but something went wrong here, and that's what we're going to talk about here. But their intention was to get 1 on the diagonals and 0s everywhere else. And then for the third one as well, they had almost all 1s on the diagonals except for the last row there. And we'll talk about what happens with those as we go on here. So then for the first one here, now remember from the previous video, this was my X column, Y column, Z column, number column. And if I go back, remember that's what I kind of talked about in the previous video here with this first one we did when we created the augmented matrices. And that's what we see here. So our first columns on the left are going to be our variables here, our variable columns. And then the one on the right here is going to be our number column. And that's what we see here. So we see the X, Y, Z, and then the number column. So this is really saying 1x plus 0y plus 0z equals -3, because we have the zeros here as well. So it's going to be 1, 0, 0, -3 if we went backwards now. But we don't need to put 0y, 0z in there. So this is really just x equals -3. And then for the second row here, that second row is really saying y equals 4, because it's really 0x and 0z there. And then for the last one, we get a 0x and a 0y plus 1z, and that equals 0. So that's my actual solution to this. This would be the 3-tuple is what they call that. 3, 4, 0. So that's what we end up with for an answer for this one, if we wanted to write it as a point. Now, looking at what this is saying after this is in reduced row echelon form. So first it said, write the system of equations corresponding to the given matrix. So that's what we did with the x equals -3, y equals 4, and z equals 0. Now it says determine whether the system is consistent or inconsistent. So when I think of the word consistent, that means it agrees. If I think of inconsistent, it doesn't agree. So if I think of each of these rows, now remember each of these rows signifies an equation. And if I go back to the previous video on this, we'll see that, hey, this was my first equation, that was my second equation. And I was able to turn those into rows here of just constants or numbers. So that's what we're doing here, the same thing. So now what that tells me here is that those 3 equations all intersect at the point -3, 4, and 0. So since they all agree at that point, I will say this is consistent. And then it says, if consistent, give the solution. And that's what we're doing right here. So for number B here, what I'm going to get here is 1x plus 0y, so I'm not going to write that in, plus 2z equals -1. Now again, I'm just looking at this first row here. So now for the second row, that's going to be 0x plus 1y plus, or I should say, minus 4z equals -2. And then for the third equation, I get 0 equals 0. Because it's 0x plus 0y plus 0z, which is 0, equals 0. Now, one thing to notice here, this is a true statement here. 0 does equal 0. But we'll talk about that in a minute. But for now, that is writing my reduced row echelon form of the system of linear equations in writing it as a system of equations. So in doing that then, now we have to determine consistent, if the system is consistent or inconsistent. And I would say consistent here, and then it says if consistent, give the solution. So when I look at this, because 0 does equal 0 here at the very last statement, then I would say this is an infinite number of solutions. And that's as far as I'll go with this one for now. Now looking at the third one here, number C, I'm going to look at this first row here. And that's going to be 1x plus 0y plus 0z plus 1w. So it's x plus w equals -3. And then I'm going to have, now remember, this is my x, that's my y, that's my z, and that's my w column. So then for my next row here, which is this one here, it's going to be 1y plus 3z equals 4. And because my w is 0w there. And then for my third equation, it's going to be this third row here. And that's going to be 1z plus 2w equals 0. And then for my last one here, my last row, it's going to be 0x plus 0y plus 0z plus 0w, which is 0, equals 1. And when I look at this system here, so first off, all I did here was write the system of equations corresponding to the given matrix. And then I have to determine whether this system is consistent or inconsistent. And for this one, it'll be inconsistent because 0 never equals 1. And I know that right away. And remember, our previous one said 0 does equal 0. So that was a true statement. 0 does equal 0. So that means I have infinite number of solutions. And this one means I have no solution. So if I have no solution here, then that tells me it's inconsistent. And I would say below that, because it says if it was consistent, give the solution. So I don't have a solution here, so there's no solution. And I can write no solution, and I should write no solution for this one.